Hello everyone and welcome to my class. I will now begin screen sharing so you can see my screen obviously. What's the other point of screen sharing? Alright, so can everybody see my screen? Can anybody see my screen? Say yes if you can see my screen, say no if you can't. Also, Steven is late today. Very bad. Yes, you can see my screen. Great. Okay, so now let's begin our class. More on inequalities. So this is our schedule. Today we will finish our unit on factoring, and then we'll work on inequalities. I'm going to assume that all of you have a basic understanding of inequalities, absolute value inequalities, unions and intersections, as well as the key rule, changing your sign when you multiply or divide by a negative number. So please do that. And then we're going to work on problems. Well, just one problem, but it's a pretty hard one. So yeah. And also I'm going to have practice problems in between every example usually. So let's start. Let's start with some warm-up questions, and please review your notes from last lecture, those who did go to my last lecture. For those new students, if you can do it, please do it. If you can't do it, please wait for me to understand. Please, if you do know how to do it, please do it and put it in the chat box. Everybody else, review your notes from last lecture and do this. Here's a hint, you have to combine the fractions. And as always, a fraction over a fraction is not simplified. So please simplify. All right. I'll see who has answered. I'll check back in a couple moments. Here is the slide. Let's see who can get it first. All right. This shouldn't be too hard. After all, it is a warm-up question. But don't be too scared if you can't do it. These are pretty hard problems. All right, so before I check your answers, this is how you combine a fraction. So A over B plus minus C over D, that's going to be equal to AD plus minus BC over BD. All right, that's how you combine fractions. So multiply these two minus these two multiplied and then multiply the bottom. So that's how you combine, and then you can just multiply x minus a at the bottom as well. So it's all good. All right. All right, we have one answer from blank. Very good. That is the correct answer. -2 over x plus 3 times a plus 3. So how did we get to the solution? And I'm very disappointed that no one got that. So no one else got that. Edward, what are you doing? Where is Edward? Did he even come? Oh, yes, Edward. You're being lazy again, aren't you? All right, so let's combine these fractions. Remember AD, so 2 times a plus 3 minus 2 times x plus 3 over x plus 3 times a plus 3 times x minus 8. All right, there we go. We have simplified some of it. So now let's do what we do. So let's simplify the top first. 2a plus 6 minus 2x minus 6. You see the 6 cancels out, and we are stuck with 2a minus x. So that's what we have. And then we have the bottom x plus 3, a plus 3, and x minus 8. And you see here, where was it? Okay, so here x minus a and a minus x, that's basically -1 times a minus x. What is that? That is x minus a, right? So what you can do is you can cancel these out and multiply a -1 on the top. So that's how you get your solution, -2 over x plus 3 times a plus 3. All right, very good, Blank. Please just have a Zoom username next time so I don't have to call you Blank. Oh, and Steven finally decided to show up. Great, Steven, just great. You're going to detention later. Yes, of course. Yep, detention for you. All right. So, number 2. This is our second warm-up question. Yes, it looks very intimidating, but please, I give you a hint. Use sum of cubes. So anyone. All right, I'll give you a few moments to try this. Steven, please do this as well. And Edward, I'm gonna be beaten by Steven if you don't answer. And yes, whoever was named Blank, do your thing. Oh yes. Well, now your Zoom new username is Blank. Oh well, their name is Blank. Great. Nice name. 2. All right, number 2, please do this. This is a warm-up question, kids. It's not that hard. All right, Blank. Did you answer? Yes, of course, it's Blank who answered again. And he is. Let's see here. He's absolutely correct. Steven, stop being slow. And Edward, stop being lazy. You're being beaten by some Blank right here. So much for rivalry. All right, so sum of cubes. Let me just remind everyone what sum of cubes is. So x plus y times x squared minus xy plus 1. That equals x cubed plus y cubed. So that is sum of cubes. So you see here, we already have the first part, right? We already have the first part. So what we need to do to simplify this to its fullest, or basically what we're doing here is rationalizing the denominator. So we can't have radicals in the denominator. That's why we need to rationalize it. Otherwise, we would keep it like this. So to rationalize our denominator, we need to not have radicals. And the thing is that it's literally being given to you, the answer. because they already put the first part in here. All you need to do is you need to multiply by 3 x squared. Hold on, just bear with me here. If you do this, according to the sum of cubes formula, if you do this, because this is the same thing over itself, that means it's just multiplying by 1, right? But this makes it easier for us to simplify. Once you multiply this, the top will be the cube root of x squared minus the cube root of xy plus the cube root of y squared over x plus y. All right. Because you see here, this is the same as our formula right here. And x cubed, x to the cube root cubed would just equal x. Same with y. So that's how we get the bottom here. And great job to Blank, who got this answer correctly. Steven, where are you? You're being slow again. All right, yeah. Plus y squared. Thank you for correcting my mistake. Yeah, it's y squared. It's y squared. I don't know why I wrote 1. Errors. A lot of errors. All right, so now let's move on to our third problem. Hopefully everybody should know this. Hopefully. So what you need to do here is you need to multiply by the conjugate. For example, a minus x is on the top. The conjugate would be a plus x. All right, you get it. All right. This should be fairly easy. I already gave you a big hint. So, Steven, please stop being slow and do the problems. Don't tell me you're in the bathroom or something doing stuff. I bet Steven is not even in the room. He's never this slow. Right. Apparently now Blank is on the computer. Great. All right, Edward, did you die somewhere or something? Where are you? Stop being slow. Edward is being slow too, with Steven. Great. Now 2 of the best people here are being slow. Great. Just great. All right, so let me give you a hint. This is what you're supposed to do. Multiply by the conjugate, and then you should get your answer. So, do that. Yep. Just do it. Okay. Any questions on the previous problems? While someone at least attempts to do this. Any questions? No questions? There should be questions because none of you know how to do it, except for Blank. And of course, Blank with another answer. It's already simplified. Oh, excuse me. All right. Yeah, that's true. Okay, then. The problem is to... All right, I didn't think I made this clear enough. But rationalize the numerator. Please rationalize the numerator. Yep, rationalize the numerator, because that's what we're doing here. And later I'll show you why we need to rationalize the numerator, and that is to find the limit of a specific equation. Find the limit or the base equation. All right. So, any answers? -1 over plus, yep, blank got the correct answer. Yes, very good. So we're going to rationalize the denominator here. And why do we need to do that? We need to find the limit of a specific thing. Okay, so I'll explain that later. So after you do this, you get this. All right, and then, okay, so plus, great. So you see here, what does this do? So, oh wait, hold on. Minus, that's minus. So you see here, canceled out, 1 minus x, 1 minus x, and you just get negative h, which cancels that as well. So I'm going to cancel it out. So you get -1 on the top, and all this boring stuff on the bottom. It's great. Why do we need to do this? I do not know. Just kidding, I know. This leads us to our next topic, finding the limit of a specific variables. And this is one of the topics of calculus. Why am I teaching calculus? I do not know why, but it relates to the subject, so yeah. So I'm going to teach you a bit of calculus, just a little bit. So find the limit. Well, basically it's free calculus. It's not hard enough to be calculus. So let's start with an example. 1 over x plus h squared minus 1 over x squared over h. So now I will show you why you need to rationalize the numerator. When you want to rationalize the numerator, you want to find the limit of a specific variable. All right. So let's say you want to find the limit of h. That's what we're going to do here. So to find the limit of that, we need to rationalize the numerator. And you'll understand later once I show this example. And that is why you need to rationalize the numerator. To rationalize the denominator is for better division. To rationalize the numerator is to find the limit. So let us very quickly simplify this first. This would be x squared minus x plus h squared. All right, x squared times x plus h squared over h. All right, so it's just x squared minus x plus h squared. Hold on. X squared minus 2 of, nope. I hate this. X squared, yep. Plus 2hx plus h squared. All right. And then that's over h times x squared times x plus h squared. So how are we going to find the limit of h? So to find the limit of h, we need to get rid of this h. So to find the limit of h, all right, to find the limit of h, just get rid of h from the equation. How do we do that? Get rid of the x terms and its influence on everything. All right, so x squared minus x squared plus 2x. All right, no h terms anymore. There's nothing. So after we get rid of the h, because we're finding the limit of the h. We can't use h in finding the limit of h. So x squared times, what is this? X squared again, because there is no h, so x plus 0 squared, and this h is non-existent as well. So therefore, we have this, which is, what is it? All right, this is actually negative. There's a negative sign here. All right, so basically we get negative 2 over x cubed. So that is the limit of h, and x cannot be equal to 0. That is the limit of h. So that's how we find the limit. And yeah, great. Any questions? Any questions? Why are there 13 participants now? It's an unlucky number. So any questions, people? No questions? I'm assuming there's no questions. I mean, I made it pretty clear. All right. No questions. Then can we move on? Is everybody done taking notes on the limit? So I'm not going to explain the limit that much. All right. We're not going to do problems on finding the limit because that's calculus. I'm not going to just teach you calculus when you don't have the basic skills of algebra yet. So, yeah. Any questions? No questions. All right. Can we move on? Is everybody done taking notes or not taking notes? Doesn't really matter. You learn this in calculus anyways. All right. Done. So simplifying more complex expressions. Now, you're going to start. How about I'll give you an example. So we're going to use the example 3x squared times 2x plus 5 to the 1/2 minus x cubed times 1/2 times 2x plus 5 to the negative 1/2 times 2. All right? All over 2x plus 5 to the 1/2. All right? Then squared. So how do you simplify this? And you might say, like, oh my God, that's very long. That looks complicated. How am I supposed to do that? Well, how are we supposed to do it? Any ideas on how we're supposed to do it? All right, please participate in this class. How are we going to go about simplifying this? Any ideas? Blank, Stephen, Edward, no? Any ideas? How are we going to do this? Well, before we even start doing anything, how about we simplify a little bit, right? How about we simplify a little bit? Don't be stumped just yet. How about we simplify the terms that we know how to simplify? All right, 1/2 and 2. Get rid of those. And 1/2 and 2 again. That's just to the first power. So the bottom is just going to be 2x plus 5. All right. So what are some methods we can use? So here's the first method. And to be honest, it's kind of stupid. But we need to do this in order for you to understand that this is a stupid method. X squared times 2x plus 5 to the 1/2 minus x cubed over 2x plus 5 to the 1/2. What is that? because this is to the negative 1/2, right? So it's a fraction. So after we do this, we combine fractions again. That's over 2x plus 5. All right, so what does this equal? This, all right, this equals 3x squared times 2x plus 5, because it's this times this. The exponent is 1/2 plus 1/2. That just equals 2x plus 5 to the first power, right? And then minus x cubed all over 2x plus 5 to the 1/2 all over 2x plus 5 to the first power. All right. And then what do? You simplify the top first. All right. The bottom we already know is 2x plus 5 to the 3/2. All right. So then we simplify the top. Okay, multiply these. What is this? 6x cubed plus 15x squared minus, well, that's basically 5x cubed plus 15x squared. All right. And if you want to simplify farther, I mean, you can take the 5 out. You can take a 5 out in an x. So let's simplify further. What was it? X plus 3. So then you're done, right? Great. You're done. So is there any other faster method we can use? Because this is so dumb. I'm just combining fractions. What if you had an even bigger one? That would be bad. So, what is our second method? So you can cancel, right? And how are we going to cancel, Blink? Oh, yep, Razor finally made it. And we're doing this. So, yes, I know you hate your life. Yep. Yeah. And you're also like, what, 32 minutes late? Have fun. Yep. Yes, that's your life. You didn't even come to last class, I don't think. That's like so many late times. If this were actually school, you'd be in detention for like 100 years. But it's fine, it's fine. You can just review the lecture later. Once I'm done uploading the video, like 6 months after this, because I'm very lazy. Oh, you went to Austin. That's cool. Austin, Texas. Right. You also go to Houston and what was the other one? Houston and Austin. Wait a second, what's the other city that's big in Texas? Houston, Austin, and so many tens. Houston and Austin. It's Dallas. The Dallas Cowboys. Yep. Right. The triangle. Houston, Dallas, and Austin. Great. All right, so now let's introduce the second method. Erase everything. All right, so Steven, you're stumped, right? Well, don't be stumped. Huh. Oh, what is this? Oh, what is this? 2x plus 5 to the negative 1/2. Oh, what do I see here? Well, why don't we just multiply it by this? It all makes sense, right? You see any negative powers? Multiply by the positive power. So, what is this? It's distributive property. All right? It's distributive property. Distributive. All right? So, you get 3x squared times 2x plus 5, just 2x plus 5, because 2x plus 5 to the 1/2 times 2x plus 5 to the 1/2, that's just to the first power. And minus this, right? It's just that. Okay? And how do we get there? Because 2x plus 5 to the negative 1/2 times 2x plus 5 to the positive 1/2, that's just 2x plus 5 to the 0th power, which is 1. So that's how we get here to here. In only one step. And then we simplify. All right. And you've made it. In only 2 steps. Multiplying by the positive power and then simplifying. So you see how the second method is so much easier? Are there any questions? And San Antonio, what is that? San Antonio. Oh my God. San Antonio. What kind of trashy? Oh, it's a city actually. A major city. Oh, didn't know about that. Things to do in San Antonio. All right. Great. So in addition to Austin, Dallas, and what was the other one? Houston, there's also another one. Texas has a lot of big cities, apparently. Great. I suck at geography, so bear with me. So are there any questions? Does everybody understand this method? Is it good? Very efficient, right? Yes, very good. Razor, you just came. How can you understand? Yes, very good. Very good. Very good method. And so, do you guys want to practice this? You want to practice this method? All right, let's do this then. Great. So, why not? Yep, why not? So, let me give you an example. Okay, example. And be careful on this one. All right, so our example is, please write this down while I'm writing it. 4x cubed times 2x plus 1 to the 1/3. Hold on, that sucks. To the 1/3 minus x to the 4th. All right, there's no bracket yet. Times 1/3 times 2x plus 5, 2x plus 1 to the negative 2/3 times 2. All right, I think we're about done here. Over 2x plus 1 to the 2/3. All right, let's do this. Practice that method I just showed you. Remember, you see a negative exponent and you gotta multiply by the positive exponent. So, yep, we're expecting answers from most of you, if you understand. Yes, I'm talking to you, Stephen and Edward. All right, I'll come back in a few moments to check answers. All right, peace out. All right, time to check answers, and there are no answers. Come on, people, it's not that hard. I just showed you the method. Come on. Anyone? Anyone? Do you need more time? Or we haven't even gotten to the inequalities. You gotta be kidding me. All right, I'm just gonna walk you through this. I have no time. Kidding. All right. This is what you multiply. It's not that hard. Because, why do we do that? You see these 2 and the 1/3, they don't always cancel out. So that's why you need to multiply a 3 as well. Again, the positive exponent, kids. It's not that hard. All right. So we simplified all that we can. So it's 12x to the third times 2x plus 1 minus x to the fourth, 2x to the fourth, and that's it. All right. And then that's over 3, 2x plus 1 to the 4 over 3. Okay, and that equals 22x to the fourth. Wait, no, that's 20, yeah. Plus 12x to the third. If you want to simplify, you can simplify 2x plus 1. All right. All right, people, let's do this. All right, we're done. We are done. Unless you insist on simplifying this, which you probably should, actually. X to the third. All right, 11x plus 6. X. There we go. We're done. Now we're done, technically. So, any questions? Hello, hello, hello. Excuse me. I am speaking right here. Can you not hear? Oh, and Edward, finally. You actually answered something. Yes. Hello, 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 hey, hello, hello. Yes. Hello, I'm right here. Can someone tell the teacher to look at this? I'm right here. Hello, hello, me. Hello, hello, never mind. Oh, right, he's already done. Are you sure about that, Blink? I think you got it wrong. Oh, wait, no, you didn't. If you can't divide it by 3, don't divide it by 3, please. Edward, stop copying other people's answers. I'm assuming you did. Why did you divide by 3 as well, when you shouldn't? Alright, fine. Great job, anyways. Great job to Blake and Edward, not to Steven. Where are you, Steven? Stop being slow. Why are you so slow today, Steven? Well, I guess you are in 4th grade, or in 5th grade. Well, he's in 5th grade, kids. Why can't you be more like him? He's smarter than you. He's learning pre-calculus right now. Come on. Alright, inequalities. That was quick. So, inequalities. A is greater than 0. So here's more about absolute inequalities, absolute value inequalities, because that's what we're gonna be working with. It's gonna be what we're working with today. All right. So, can anybody tell me what they know about absolute inequalities? What do you know about absolute inequalities? All right. So let me tell you, this is extremely important, kids. So if you do not know this, then be prepared to be doomed. So take out your notebooks and calmly write down this. All right. So if the absolute value of x is less than a, that means that x is less than a, and it is greater than negative a. All right. So you get this. On the number line, it is this. It's an interval, right? Now, if the absolute value of x is greater than a, assuming a is greater than 0, if it's negative, then the absolute value is greater than a negative number. That's all real numbers. Assuming a is greater than 0, the absolute value of x is greater than a, then that's x is greater than a, or x is less than negative a. So or. So the interval here would actually be two of them. One pointing there, one pointing there. So this is extremely important when you're graphing and you're answering absolute inequalities. So, any questions? Your mind is fuzzy? Well, get rid of the fuzz. Did you drink like beer or something? Are you drunk, Steven? Stop being drunk, Steven. I swear you were drunk today. Great. Drunk on Kool-Aid, I see. What more can be more disastrous than that? All right, so inequalities. So interval notation. Everybody knows what interval notation, right? Great. Now I have to teach it to you. That's great. So interval notation denotes an interval. For example, 2 to 5. Now, this dot, this filled in circle, means the number is included. So you use these square brackets, 2 to 5. Square brackets mean they are included. Now, if you have 2 to 5 here with open circles, that means not included. So you use parentheses, 2 to 5, but not included. Great. Any question? No questions? Any questions? All right. So that is interval notation and union intersection. Yikes. So, how about, does anybody know what unions and intersections are? Yes, very good. Yes, very good. So what is a union? All right, let's use this. Let's use a diagram to do this. All right, so this is a very trashy Venn diagram. Hold on, let me make it less trashy, or at least attempt to. Oh, that's better. So this is A, and this is B. So the union symbol. Hold on. The union symbol is this, just the intersection symbol is this, an upside down U. That's intersection. So what is union? Union is combining A plus B. That's A union B right there. You see the shaded region in between? That right there. Hold on. That right there is A intersection B. So what is union and intersection? Intersection is you have segment AB, and you have segment CD, all right? C and D. So hold on, let me use the highlighter. You have segment CD, and you have segment AB. So you see these two segments. What is the intersection? What is the intersection? The intersection would be CB because that is what they have in common. It's like a Venn diagram. One side is only A, one side is only B. The both part is what A and B have in common, which is C and B. CB, intersection CP right here. So that is basically intersection. Now, what if we had, hold on, why am I still on highlighter? We have segment AB and I'm trying to find a, all right, let's do this. We have segment BC. Great. So AB union BC, what is that? Union means you combine them, right? You're combining them. So AB, segment AB, union segment BC would equal AC because you're combining them. You're taking everything and squishing it together into one. Intersection is finding the common thing and taking it out. So intersection, think of it as taking something out. It should be smaller than both of those segments. But union, it should be bigger than both of those segments because you're combining them, right? So think of it as that. So that is basically union and intersection. Are there any questions? Any questions? Steven, stop saying yes to being drunk. Is that a yes for being drunk or a yes for knowing unions and intersections? Hopefully it's not being drunk. And alcohol is not sugary, Steven, in case you didn't know. Oh wait, you're a fifth grader. I should not tell you that. Oh yeah, he's drunk on Kool-Aid. Well, he doesn't drink sugary stuff. Does Capri Sun count as sugary? Capri Sun? I grew up on Capri Sun. I had like one pouch of Capri Sun every year. Like that's a lot. And intersection, both great. So interval notation with union and intersection. Have fun, kids. This is probably the hardest problem of, well, no, this is not close to the hardest problem I'm going to give you. I'm going to make you suffer with these inequalities. So how do you do this? Any ideas? Or are you stumped? And please answer in interval notation. No using algebra calculators. Even though you probably will. I'm talking to you, Edward. Yes. So any answers? No answers. All right, let's do this. Shit. All right, problems. Oh, well, it's an absolute value inequality. I'm so scared. So, with absolute, what is this? What is this monstrosity? So, with absolute values, there's two. All right. There's two. There's two answers, right? If x is less than 4, right? So your x less than 4. Okay, great. So what you need to do is one, take off the absolute value sign, and right, and I mean no, it's or wait, no, or -4 and -2. You see what I did here? I switched the signs as you're supposed to do with absolute value. All right, and I switched the numbers as well. Make sense. So now you solve. It's not that hard. Maybe a little, but it's not that hard. All right. So what do you get here? Well, I do not know. What you get here is, well, you switch the signs, obviously. You get X. -2. All right, we're done here. Okay. You divide by -2 on all sides here. And then because you divide by a negative number, the grand rule of algebra, all right, switch the signs. Okay. Good. Or you can get what? You can get what? Divide by -2 again. Why don't we just switch the signs again? Great. That's just great. All right, now. That's what we get. Huh, the same exact thing. Huh. Great. So now we are done. Right? How are we going to put this in interval notation? I do not know. I'm just kidding, I know. The union sign. Very nice. You see here, go from -2, which is not included, and then you go to -1, which is included. Union, you go to 1, which is included, and get a 2, which is not included. So the answer is -2 to -1 included to 1 included to 2. Union. Right, so that's how you use interval notation to denote it. Great. Oh, wow. You are good. Great. Everybody got it correct. And you also put it in interval notation. That's good. Great. So that was the last problem of our class. Thank you for listening, everybody. Actually, why don't I just screw out the sun here? There is no sun, there is no sunshine, there is no Christmas, there is no Santa Claus. Have fun, everybody. Darkness awaits you. I'm hungry now. All right.